At 5:09 in the morning on Saturday, June 13, 2026, monitoring equipment installed in Yellowstone National Park's Biscuit Basin registered anomalous seismic energy and a low-frequency acoustic signal called infrasound, both coming from the direction of Black Diamond Pool. A camera that had been installed at the pool in May 2025 captured what happened next. A dark-colored plume of steam and debris jetting out of the ground just north of the pool. The footage lasted seconds. Then the ground went quiet. Later that morning, a park staff member checking the Firehole River noticed something odd. The water, which runs clear through this stretch of Wyoming wilderness, had turned milky gray, a light-colored plume stretching 3 to 4 miles downstream. 2 new runoff channels had opened up, draining hot, sediment-laden water from Biscuit Basin into the river. The river stayed that color for only a few hours, as long as the new vents kept draining. Then it cleared. When geologists arrived the following day, they found 3 sets of newly formed vents in the ground. The largest was a crack to the north-northwest of Black Diamond Pool, measuring 18.5 meters, 61 feet long, and up to 1.5 meters, or 5 feet, wide in places. It was filled with near-boiling water and surrounded by rocks that had been ejected during the explosion. A second vent to the northeast measured 49 feet in length and had already stopped flowing, but the fractured rubble around it still held water measuring 89 degrees Celsius, 192 degrees Fahrenheit. A third vent group completed the perimeter. When the team returned 2 days later on June 16th, they found something they had not expected. Ground they had walked on just 48 hours earlier had become an actively boiling pool. Gray, silty, 21 feet by 17 feet, with what geologists described as notable thumping from steam bubbles, forming and collapsing beneath the surface. By June 18th, the new pool had begun intermittent spouting episodes, jets of hot water reaching between 20 and 30 feet into the air, stopping, then resuming. As of this week, it has not stopped. This happened 13 days ago. It happened 2 miles from Old Faithful. And scientists at the Yellowstone Volcano Observatory say it represents the most important data opportunity in the history of Yellowstone hydrothermal research. To understand what Biscuit Basin just revealed, you have to understand what Yellowstone actually is, not the park, but the system beneath it. Yellowstone sits on top of one of the largest supervolcano systems on Earth. Beneath the surface of northwestern Wyoming, southern Montana, and eastern Idaho, a hotspot in the mantle has been punching through the North American plate for millions of years, fueling 3 catastrophic caldera-forming eruptions: 2.1 million years ago, 1.3 million years ago, and 640,000 years ago. Each of those eruptions dwarfed anything in modern recorded history. The caldera visible at Yellowstone today, roughly 45 miles wide, is the scar left by the most recent one. But Yellowstone's daily hazard is not magma. It is water. The park hosts more than 10,000 hydrothermal features: hot springs, fumaroles, mud pots, and geysers. Approximately 500 of those are geysers, more than exist anywhere else on Earth. Old Faithful erupts every 60 to 110 minutes, sending water up to 180 feet into the air on a schedule reliable enough that rangers post predicted eruption times. All of this activity is driven by the same heat source that drives the volcanic system below: magmatic heat-warming groundwater that has percolated deep into the crust. In Yellowstone, the boundary between a tourist attraction and a geological hazard is measured in inches of rock. Biscuit Basin sits less than 2 miles northwest of Old Faithful. Under normal conditions, it is a boardwalk loop through a collection of colorful hot springs and small geysers that draws thousands of visitors per day during peak summer season. Those boardwalks have been closed since July 23, 2024, when a significantly larger hydrothermal explosion occurred at the same Black Diamond Pool, blasting rocks and scalding water into the air, destroying the boardwalk infrastructure, and forcing an indefinite closure of the entire basin. That 2024 event left a clearly visible crater and prompted the installation of the camera and monitoring equipment, whose data is now at the center of the June 13th investigation. The June 13th explosion was smaller. The rocks it ejected traveled only a few meters. The crack it opened was 61 feet long rather than the wider scar left in 2024. No one was harmed. The closure that followed the 2024 event is the only reason anyone can say that. But scientists are not measuring the significance of June 13th by its size. They are measuring it by where it happened. The explosion occurred approximately 100 meters, 328 feet from the Biscuit Basin monitoring station that was installed in summer 2025. According to the Yellowstone Volcano Observatory, no hydrothermal explosion has ever occurred that close to an operating monitoring station in the history of Yellowstone research. That proximity means that whatever seismic or infrasound signals existed before, during, and after the explosion, signals that might constitute the first ever documented precursors to a hydrothermal event, were almost certainly recorded. Scientists are now spending weeks analyzing that data, looking for the patterns that might, for the first time, allow them to see an explosion coming. That matters because of what hydrothermal explosions actually are and why predicting them has been so difficult. A hydrothermal explosion is not a volcanic eruption. No magma reaches the surface. Instead, the mechanism is water. In Yellowstone's subsurface, groundwater is superheated by magmatic heat to temperatures well above the normal boiling point of water. At depth and under pressure, that water remains liquid. Pressure suppresses the phase transition to steam. When something suddenly releases that pressure, a micro-earthquake, a geological shift, a new fracture in the overlying rock, the superheated water flashes to steam almost instantaneously. The conversion from liquid water to steam involves a volume increase of approximately 1,600 times. That explosive expansion is the hydrothermal explosion. It ejects water, steam, rock, and sediment from whatever pathway the pressure found to the surface. At Biscuit Basin on June 13th, the mechanism was precisely this. Water at or slightly above boiling temperatures beneath the ground found a new pathway to the surface and converted. 3 vents opened. 61 feet of ground cracked. And the new pool that formed 2 days later formed not by explosion but by collapse. The same ground, now undermined by the loss of subsurface material, simply sank. Scientists know this because there was no debris ring around it. It fell rather than blew. The history of hydrothermal explosions at Yellowstone ranges from events like June 13th to something of a very different scale. Roughly 14,000 years ago, a hydrothermal explosion in the area now known as Mary Bay left a crater approximately 1.5 miles across, a scar visible in the topography of Yellowstone Lake's northern shore today. That explosion was water, not magma. It produced a crater larger than many volcanic calderas, triggered by a rapid drop in the lake's water level, reducing pressure on the superheated system below the same mechanism as June 13th at a scale that is difficult to comprehend. Yellowstone receives approximately 4 million visitors per year. Old Faithful alone draws an estimated 25,000 to 30,000 visitors on a peak summer day. Biscuit Basin normally receives millions of visitors annually. Walking the boardwalk loop past Black Diamond Pool without knowing the ground beneath it is hydrothermally active at near boiling temperatures. The 2024 explosion that destroyed that boardwalk happened early on a Tuesday morning in late July, peak season, before the crowds arrived. The 2026 explosion happened at 5:09 in the morning, in an area that had been closed for 2 years. The Yellowstone Volcano Observatory's current alert level is normal. Aviation color code is green. The caldera shows no signs of significant uplift or subsidence since December 2025. The seismicity in May 2026, 45 located earthquakes, largest magnitude 2.0 bar, is consistent with background levels for the region. There is no indication that Yellowstone is approaching a volcanic eruption. Hydrothermal explosions are a different category of threat. They require only 3 things: superheated water, a sudden pressure release, and a pathway to the surface. Those conditions exist throughout Yellowstone's thermal basins at all times. The system that drives Old Faithful to erupt every 60 minutes is the same system that drove Biscuit Basin to crack open on June 13th. The difference between the two is the geometry of the plumbing, the depth of the heat source, and the specific pressure dynamics of each individual feature. Scientists have known about hydrothermal explosions at Yellowstone for more than a century. They have documented them, studied them, and failed to identify reliable precursors. That remains true as of today. But what the June 13th explosion may have provided, 100 meters of proximity to a monitoring station recording in real time, is the closest thing to a controlled experiment that Yellowstone has ever accidentally produced. There are 3 signals scientists are watching in the weeks ahead. The first is the data analysis. Researchers are working through the recordings from the monitoring station installed just 100 meters from the June 13th explosion site. If any pattern emerges in the hours or minutes before 5:09 a.m., any seismic signature, any infrasound anomaly, any temperature shift, it would be the first documented hydrothermal explosion precursor in Yellowstone's research history. That finding would change how the park monitors its thermal basins. The second is the new pool itself. As of June 18th, it was spouting intermittently to 20 to 30 feet and boiling continuously when not spouting. Whether it stabilizes into a permanent new feature, whether it grows, or whether it triggers additional subsurface changes in the Biscuit Basin area is an open question being monitored daily. The third is Black Diamond Pool. It produced a large explosion in 2024. A smaller one occurred 13 days ago from a vent just north of it. The pool itself is now showing intermittent spouting behavior that was not present before either event. Whether Black Diamond Pool is building toward its own release, or whether the June 13th explosion relieved the pressure that might have caused Wandar, is the question scientists cannot yet answer. What happened at Biscuit Basin on June 13th was small. The crack was 61 feet long. The new pool is 21 feet across. No one was hurt. By Yellowstone's historical standards, it barely registers. But the last time scientists had this much real-time data from this close to a hydrothermal explosion, the event had not happened yet. Now it has, and the recordings from 100 meters away are waiting to be read. Subscribe to stay ahead of what's coming.